part of the video, we're going to be going over a class of vulnerability known as SQL injections, which are the mixing of code and data within a SQL query. Since SQL queries pass a string to the database, if the data passed within the query contains valid SQL commands, those commands will be executed in the context of the query. On the screen, you can see an example SQL query given. This query selects a single user from the users table with the given user ID and access level. With a normal case, the user will be selected correctly based on the user ID, which is an integer, and will be passed if the user is an admin, having an access level greater than 1. However, this relies on the user ID field being an integer value. If a value such as a string is passed to the user ID field, such as the string seen in the second query, 1 or 1 equals 1, this actually changes the nature of the SQL query. In the second query, you can see that the user ID is selected if it is 1 or if 1 equals 1, which is true in all cases. In other words, this will select any user from the database that has an access level of 1, essentially bypassing the authentication check. In a more malicious query that can be seen here, the user table is actually completely dropped within the context of the query. This can be accomplished using the SQL comment, which comments out the access level part, which would make it an invalid query. SQL injections and injections in general were recently classified by OWASP as the #1 threat in their top 10 list of 2013, so it's important that these are addressed within your application. For this part of the video, we're going to be demonstrating this attack with the Grails.nv app, which we recently open sourced. Grails.nv is a vulnerable jobs listing application that contains numerous vulnerabilities and tutorials on how to find, identify, and fix them. This makes it a perfect platform for demonstrating SQL injections. Within the Grails.nv app, we can see the user profile page contains 3 pieces of information: the ID, the username, and the description if the user has set one. In the URL, we can see that the user ID is present, in this case 3. What happens if we change this ID? In this case, we just need to change it to 2, and we get a different user's profile page. This means that the profile is dynamic and the ID given to us is being passed to the query. As we can see in the code, the ID is directly passed in the query as a user is chosen when the ID matches the parameter given. So because there's no encoding or escaping done on the parameter as it's passed, we're vulnerable to injection. And up here, we simply check for the existence of the parameter, not its type. In order to address this, we should use the Grails ORM, known as the GORM, which provides an easy acceptor method for getting any object based on its ID. All invalid IDs or non-integer IDs will simply be rejected and caught by our error handler. So to do this, instead of defining user data by the query, we should define user data using the user.get method, which is a dynamic method added to all classes in your model. By passing the ID to the get method, we're able to retrieve the object based on the parameter ID, and we don't have to do any checking for SQL injection. It will automatically escape and parameterize the query for us, and we don't have to worry about malicious queries or invalid queries being passed to our database. Another place in Grails.nv we can find this problem is on the login form with the email and password fields. If we take a look at the code, we can see that the email and password are put directly into the query, again with no escaping or encoding done besides the hashing of the password. This opens us up to SQL injection again. In order to address this, we should look to use the Grails GORM and pass the values to the database as a map and let the ORM worry about generating the query for us. This can be done in Grails with the find or findWhere method. We simply specify the fields that we're passing to the database, in this case, the password and the email, and Grails will handle generating the query for us so we don't have to worry about escaping or encoding things for the raw query. Again, this handles finding the user object and returning no objects if there's an error, so that our error handler can just handle it like normal. In the second part of this video, we're going to be talking about broken authentication and session management. So oftentimes, developers like to roll their own authentication and session management systems, and while this is okay and it simplifies development, it also leads to the propagation of common vulnerabilities that others have addressed but developers didn't consider, which is why OWASP decided to mark broken authentication and session management as A2 on their top 10 list of vulnerabilities. Common type is an improperly configured account lockout, which occurs when an account must be reset after numerous failed login attempts. As you can see on this site, when I attempt to log in once and my credentials are incorrect, it tells me that I have an invalid login. If I continue to attempt to log in each time with invalid credentials, my account will eventually become locked and I will need to reset it from my email. Most sites associate whether or not an account is locked and the number of tries that have been attempted with your session so they can be matched to your IP. Unfortunately, this creates the problem that if my session identifier is reset, the token and the number of tries that I have attempted are also reset. In this example, if I clear my cookie, you can see that I will now be able to log in again, this time with the correct credentials, despite the fact that my account is locked. If we look at the code, you can see that all of the values relating to the lockout are stored within my session, the cause of the problem. Since your session is tied to a value control on the client side, this allows attackers to bypass the account lockout simply by clearing the session after every request. A better way to handle account lockouts is to associate these values with the user object in the database. This has the additional benefit of preventing botnets and mass attackers because once an account is locked once, it will be locked for all further attempts from any computer. This commented out section of code instead stores the lockout number of attempts and the lockout ID on the user object, which prevents the attack that we just mentioned and allows for a more secure account lockout system. One example of poor session management is an improperly configured session timeout. This occurs when the user session is set to not expire in a timely manner or to not expire at all. This means that an attacker who compromises the session cookie can continue to use it for an indefinite amount of time. In this case, you can see that Grails.nv is not set to expire the session identifier until 2015, over a year in the future. If we take a look at the configuration for the cookie, we can see that it's actually set to never expire, meaning that Grails will continue to perpetuate the session indefinitely. A better value for the session timeout will be to set it to expire every 30 to 60 minutes, meaning the user is required to authenticate themselves again at that time. While setting a session timeout cannot prevent attacks, it can help to slightly mitigate their impact by requiring the user to re-enter their credentials, verifying that someone who simply steals the session identifier cannot log into the account for an indefinite amount of time. In addition, it's important to realize that a compromise is made to user experience by setting a short session timeout, so it's important to strike the right balance. A third common form of attack against session management is session fixation. Session fixation occurs when the system both doesn't change the session cookie during authentication and allows any arbitrary session cookie to be used. In this case, you'll notice that the value of my cookie during login does not change before and after I authenticate with the system. This means that the system is vulnerable to session fixation. You'll notice that the cookie value has not changed. In order to address this in Grails, we must actually invalidate the session when the user logs in and then set it on their next request. Session invalidation is the only way to change the session identifier in Grails. So to do this, we move over to the code, and we notice that we must invalidate the session here after the user has been authenticated. Also store a flash request with your user ID, which will be passed to the filter that determines whether or not a user is authenticated. In the filter, we check for the presence of your user ID and then pull your user object from the database and store it in the session at that time. Using this code, the session identifier will be changed and your user object will be stored in a database before any operations are performed on it. If we now check the cookie value before authentication, we will notice that it does indeed update after we authenticate with the system. This means that our system is no longer vulnerable to session fixation. I'm Cyrus Malikpour. This has been another episode of SecCasts. Thank you for watching.